Okay, recording now.
Okay, good evening to everyone. Thank you for coming. I would also like to thank the organizers of the True Bugs Tuesday for the opportunity to talk a little bit of my project. This project is developing in collaboration with Felipe Moreira. And this study is being developed in the entomology lab of the Instituto Oswaldo Cruz in Rio de Janeiro. And the title is Rearranging Veliinae, Classification under a Phylogenetic Context with focus on the America genera. Okay, this family, Veliidae, consists of small to medium-sized insects, 3 to 10 millimeters. And these insects live mainly on the water surface, and there are currently more than 600 described species, divided into 4 subfamilies: Veliinae, Ragoveliinae, Veliinae, and Pelitopini. So the subfamily Veliinae, the target of our study, can be diagnosed by the absence of the ocell in the head, forewing with 4 closed cells, not divided into coriaceous and membranous parts, tarsal formula 333, and middle tarsus without a plumose or hair swimming fins. It's very easy to identify the subfamily. So the subfamily is found worldwide, and it has 12 genera, and most of them are restricted to the neotropical and Nearctic regions, while others are restricted to Europe, Africa, and Asia. So these insects live in different types of environments. In general, they are associated with emergent vegetation in ponds and streams. And although some lineages have adapted to live in specific environments, such as water filled in bamboo internodes, inside the farms, sandstone caves, and inside the water accumulated in bromeliads, and even far from the water. So these insects are predators and feeding of small insects that fall in the water. So here I present a plate with pictures of dorsal aptitudes of one species from each of the 12 genera. So on the left are the American genera, and on the right, the genera from the Palearctic, Afrotropical, and Oriental regions. So these 3 genera has the distribution in the Eastern Hemisphere. So in this table, we have the distribution of each genus with its respective number of species. In total, the subfamily has 173 valid species, and the most specious genera are Paravelia, with a neotropical distribution and 46 species, and Velia, the type genus of the family, with Palearctic, Afrotropical, and Oriental distribution, and has 4 species. So here are the distribution areas of each genus. Some of them are widely distributed, while others are more restricted. For example, the genus Angulovelia is restricted to the Southeast Asia and have just 1 species. So among the American genera, most of them are restricted to the neotropical region, with the exception of Platyvelia and Stenovelia, which have records in the North United States and probably Canada. Here, I highlight two genera that have a more restricted distribution and alta valia associated with the mountainous regions of the north portion of the Andes in South America, and the genus Veliidae that occurs from Mexico to the north of South America. So here I present a brief history of the phylogenetic hypothesis for the subfamily Veliinae. So I begin with the classic study by Anderson from 1982, who proposed a hypothesis based on morphology, which was the phylogenetic basis for the next 20 years. In this study, Veliinae was recovered as a sister group to Perutopini. In 2004, Anderson and Weir revised this classification, also based on morphology, and found no support between Veliidae and Perutopini, but rather polytomy between Perutopini, Higor and Veliinae. 4 years later, Dungard proposed a hypothesis with morphological and molecular data and did not recover the family Veliinae as monophyletic with two subfamilies, Microveliinae and Haloveliinae, closer to Giardia than to other Veliidae. But in this case, the authors was conservative and did not make taxonomy changes. More recently, Armisen et al. Proposed a transcriptome-based phylogeny for geomorpha, and also could not recover Veliidae as a monophyletic family consisting of successions of clades sister to Giardia. So in this study, the authors allocated the subfamilies Microveliinae and Haloveliinae within the family Giardia. So Veliinae is not a monophyletic. Specifically to the subfamily Veliinae, the same is also true for the subfamily, and in which Veliidae was recovered as a sister to all other clades of Veliidae plus Giardia, while a clade containing species of Euvelia and Paravelia bulliolata is sister to Ragovilia, not to the rest of the subfamily. Also, the genus Paravelia was recovered as a polyphyletic. So you can see here. So specifically regarding the genus Paravelia, its paraphyly has been hypothesized by several authors, but without a phylogenetic basis. Here we have photos of the dorsal aptus of 18 species of Paravelia, showing the general shape and the variation of the spots on the forewing. So we can still consider the study of the relationship among species of Paravelia premature, because only a few members have been included in the published analysis. So therefore, our objectives with this project are to study from a phylogenetic perspective the relationship among genera and species of Veliinae, when I focus on an American taxa, to test whether American genera are recovered as monophyletic, and to describe in the illustration little no species. So we constructed the matrix in Mesquite, and we constructed characters optimization in TNT based on parsimony analysis. Our matrix has 86 terminal taxa, 3 of which are outgroups, and we routed our tree and Mesovellium such. As preliminary results, I highlight that all American genera were recovered as monophyletic, except the genus Parvelia, and we found low support for genera relationships. However, for some internal clades, we found high support. So the genus Parvelia was recovered as polyphyletic, as hypothesized by several authors. So we had in the topology are the species currently including in Paravelia. So here's the type species of the genus Paravelia basalis. Okay, the first I will talk about some clades of the final topology. And the first involved the relationships between the genus Calivelia and Platyvelia that together form the sister group of Stenovelia. And some synapomorphisms of this clade are shape of dorsal indentations, ocular seta absent, and absence of small tubercles between meso and metastanar. And this clade, Platyvelia and Calivelia, was also recovered by Armisen and collaborators in 2022. You can see here, Platyvelia is more related with Calivelia cornata. Another clades involved the genus Stridulivelia, a genus recovered as monophyletic. However, the subgenera probably do not form a natural groups, since the subgenus Zenictovelia was not recovered as monophyletic. So currently, these two subgenera are differentiated only by the presence or absence of stridulator areas in the hind femur and on the lateral margin of the abdomen. So probably the subgenus Anectovera is not a monophyletic subgenus. Okay, Paravelia species that live in water accumulating inside bromeliads and bamboo nodes are close to each other compared to other species of the genus. So for example, here species of bromeliads and species from bamboo internodes. So specifically about the species living in bromeliads. So these species have sexual dimorphism in the hind leg. Males have a clavate tibia, while females have a cylindrical tibia. And also males have a very characteristic hound of spine on the hind femur. And finally, the posterior margin of the pronotum also has a small projection. So, and about the species of water-filled bamboo internodes. So these three species are also very similar to each other. So you can see the spot on the forewing, the body shape, the shape of the body, and also these species share a small projection on the posterior margin of the pronotum, and a row of robust spines on the hind femur, and a fringe of seta on the hind tibia. And this feature probably is present only in males. Okay, another clade. So we have these two species of Paravelia in a very similar morphology, including the shape of the tarsomeres. So one of them is often collected on foam and Paravelia bulliolata, a habitat shared with the genus Oiovelia that's very common living in the foam. So here, the topology of Armisen and collaborators 2022 also recovered some species of Oiovelia together with Paravelia bulliolata. However, due to the several morphological inconsistencies with Oiovelia, these two species probably belong to a separate lineage, but close to Oiovelia, as suggested by Armisen and collaborators. So another clade here, we have 7 closely related species whose bodies are covered with small black denticles, and their forewings have a very similar pattern of spots, and probably can be another good genus, new genus. And the type species of Paravelia basalis that defines the genus is not related to the previously mentioned clades, and such species will be removed in future studies of the genus Paravelia. So here is a plate of the type species of Paravelia, and very different of the other species of the genus. Okay, so we are working with some genera of the Eastern Hemisphere. So the genus Angelia is one of the genera of the subfamily Veliinae that occurs in Africa, Madagascar, and Southeast Asia. And we are working in this paper now, and we found new species, synonymy, and new records, and we are preparing also the checklist of all species of in this genus. It's a very beautiful genus, and we have a pictures of a live specimens here. Okay, for the next step, we need to increase the number of samples for molecular studies, because sometimes it's so hard to identify homologies among the genera. And I would like to add continuous correctors, a lot of measurements, and the exploration of pretarsal structures by scanning electron microscopy. So we will develop this part in the next year. Okay, as a final considerations of my presentation, so all the Veliidae genera from the Americas, except Paravelia, were covered as monophyletic, and Paravelia is polyphyletic, aligning with Armisen and collaborators. And some species will be reassigning to the new genera. And finally, the genus Velia, the type genus of the family, likely belongs to a distinct lineage from other American genera. And I'd like to thank the project funding and curators, collection managers, and colleagues who have sent material for study. And thank you so much.
Thank you, Igor, very much for this great presentation. The bugs look great. If people have any questions,